Witnessing the fact that we are part of a moving solar system in which you have the Earth, Sun, and Moon interacting together. As a person, I felt very moved when I saw totality in the middle of the day. Totality is when the moon covers completely the sun, and so all the light that we normally see during the day from the photosphere of the sun completely disappears, and the only thing that you are left seeing is a dark sun, completely blackened, and then on the outside of the sun, the corona is visible. So we're going to show you what happens to create totality, to create this darkness in the middle of the day on the Earth's surface as a result of a total solar eclipse. So basically I have a fictitious sun behind me, which is a light source, pretending that it's the sun, and we have the Earth and we have the moon. So the moon actually travels in front of the Earth, covering the sun, and that's what causes the total solar eclipse. Did you see that shadow, Lily?
I did.
There it is. So basically that shadow creates what is called a path of totality, which will be a strip of darkness. This is not exactly to scale, but it is helpful to see. It's very simple. The shadow of the moon is cast upon the surface of the Earth. The moon is indeed much smaller than the sun. 400 of these little moons will actually cover the diameter of the sun. But the moon is also 400 times closer to us, and that is what creates the total solar eclipse, which is an amazing cosmic coincidence. So to illustrate what I'm talking about, I'm going to use my thumb, which is much smaller than your head, to try and cover it. So if I try to cover it here, I close one eye, you're still very visible. But if I bring my thumb very close to my eye, eventually your entire face is actually covered. And that is what's happening. And you can try this at home. Do that with different objects and different distances using your thumb and closing one eye, and you'll be able to understand why the moon, which is 400 times smaller than the sun, but is 400 times closer to us, can actually cause the sun to be completely obscured in a total solar eclipse.
If the moon goes around the Earth once a month, how come we don't have an eclipse every month?
The orbit of the moon around the Earth is actually slanted, so most of the time the moon will actually travel above the plane of the Earth and the Sun line or below the plane of the Earth-Sun line and not cause an eclipse. We are not going to have a total solar eclipse forever. And that is because the moon is actually receding from the Earth. The distance is actually increasing due to tidal forces. And so, of course, as the moon recedes from the Earth, it covers a little bit less and less of the solar disk during an eclipse. But this will happen in 500 million years. So we still have time to go out there and catch a beautiful total solar eclipse.
As the darkness slowly encroaches,
total solar eclipse coverage through the eyes of NASA. At 1 p.m. Eastern, only on NASA television.
On August 21st, 2017, a solar eclipse will pass
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
Hi, I'm Noah Petro from NASA's Goddard Space Flight Center. The eclipse has just passed over us here at Volcano Stadium. You all in Charleston have a great show coming your way. Now, because we've got NASA at both stadiums today, we wanted to connect the two events, creating a transcontinental eclipse doubleheader. Now, I know Paul Hertz is there today. Paul's the Division Director of Astrophysics at NASA headquarters. Now, Paul, we've got a ball here to send your way. Now, Paul, I'm going to throw it as hard as I can. I hope you can catch it.
Great throw, Noah, but I don't think either one of us is ready for the majors. I'm here at Charleston Riverdog Stadium, and we're looking forward to a beautiful eclipse and an exciting ball game. And I hope everyone at Volcano Stadium enjoyed the eclipse and enjoys the rest of your ball game. Today is a great day for America, for baseball, for NASA, and for anyone who enjoyed the great American eclipse. Thank you.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
What we're talking about is several visualizations of the path of the moon's shadow during the eclipse in 2017. Everything in it is driven by the data. So the color of the ground, the position of the path of totality, the lighting from the sun angle, all of those are things that are based on data. A lot of NASA products were used to create this visualization. I used the Lunar Reconnaissance Orbiter, the laser altimetry data from that, which gives us a digital map of the elevations on the moon. For the Earth, I used something called SRTM. This was a radar that was flown on the space shuttle. For the positions of the Earth, the moon, and the sun, I used a JPL ephemeris. An ephemeris is just a list of positions, but it's the most accurate tabulation of those positions. This visualization is unique because it shows the effect of both the irregular edge of the moon, the limb of the moon we call it, and the elevation of the observer. Now, we've known for a long time that the elevation of the observer affects where the shadow is, and we've also known that the mountains and the valleys along the edge of the moon affect the shadow. So you may have seen on eclipse maps in the past that the image of the umbra, that shape of the shadow on the Earth, is drawn as a smooth oval. But we know that the moon isn't smooth. Around the edge of the moon, we have these sort of jagged peaks and valleys. And a peak can block the sun a little bit earlier than you thought, and a valley can let the sun in a few seconds longer than you thought. The combined effect of these peaks and valleys is to create a shape that's not really an oval, it's more like a polygon. But it hasn't actually been seen in exactly this way before, where we calculate those circumstances for every point on the map and draw that shape. Totality is that 2 minutes when or 2.5 minutes when the moon completely covers the sun. The sudden darkness of totality is just something that a lot of people can't compare to anything else. I love the idea that I'm giving this kind of map to other people, and especially that it's more detailed and more accurate so that people are actually in the right place to see it.
Watch NASA Television's pre-show coverage at 12 p.m. and the entire total solar eclipse coverage through the eyes of NASA at 1 p.m. Eastern, only on NASA Television.
Looking back at Earth from a million miles away, the Deep Space Climate Observatory will watch the August total solar eclipse in real time, giving scientists a unique opportunity to study our solar-powered planet. NASA's Earth Polychromatic Imaging Camera, called EPIC, will capture images of the moon's shadow passing over Earth. A team of scientists will combine data from EPIC with measurements taken on the ground to learn more about how the sun's energy is absorbed and reflected in Earth's atmosphere. Clouds affect how much of the sun's energy reaches Earth, which can be difficult to calculate without knowing how each cloud blocks, absorbs, or transmits light. Like a giant cloud, the moon blocks out the sun's energy during the solar eclipse. Because we already know the exact shape and makeup of the moon, scientists can use the natural phenomenon to develop new calculations that could improve estimates of Earth's energy system and answer questions about Earth's climate. NASA has studied the Sun and Earth relationship for more than 40 years. This year, NASA is launching 2 instruments to further study Earth's energy system.
Studying total solar eclipses have revealed some of the most fundamental discoveries in science today. During these celestial events, scientists discovered the sun structure, the first proof of Einstein's theory of general relativity, and the element helium 30 years before it was found on Earth. They also discovered huge solar explosions called coronal mass ejections, eruptions on the sun that continue to be an important component of NASA's research. Coronal mass ejections, or CMEs, are giant eruptions made up of hot gas and plasma. From the sun's surface, they propel immense clouds of solar material into space, speeding at up to 1 million miles per hour and carrying enough energy to power the world for 10,000 years. Sometimes they're directed towards Earth when they can affect our planet's space environment, causing space weather. Scientists track and study CMEs because they can trigger global changes in Earth's magnetic field. When intense, these can create magnetic storms that can cause aurora, but can also affect satellite electronics and power grids on the ground. Scientists discovered these eruptions in the 1970s during the beginning of the modern satellite era, a time when satellites in space were able to capture thousands of images of solar activity that had never been seen before. But in hindsight, these might not have been the first time scientists had noticed these solar features. Soon after they discovered CMEs, scientists came across reports of a total solar eclipse in 1860 that looked very similar to their satellite images. On July 18, 1860, the shadow of the moon travelled over North America, Spain, and North Africa before departing Earth. Much of the path of totality travelled over populated land, resulting in a wealth of observations. Back then, astronomical photography was still new, so many scientists recorded their observations by hand. The drawings show the large white fingers of the corona, and also a distinctive arc-like feature. With multiple images drawn from different locations across Europe, it appears to evolve over time. But not all the images showed this. About 2/3 of people saw the tulip head-like shape, but 1/3 didn't see anything at all, including renowned scientist Angelo Secchi. It wasn't until over 100 years later, with regular satellite imagery, that scientists reopened the debate about what was seen in the 1860 eclipse. The strong resemblance shows that this eclipse may be the first record of a CME. While satellites in the space age exploded the field of CME research, total solar eclipses seen from the ground still provide unique views of the sun's atmosphere that help our understanding of what causes these explosions. Current instruments in space studying the corona need to block the sun's bright body with an occulting disk. The disk covers up the sun and a portion of the lower corona, an important region that scientists believe is responsible for accelerating CMEs and forming solar wind. So when eclipses happen to fall on land, scientists take advantage of these rare events. With each new total eclipse, there's the chance for new information and new research, and the chance to reveal something as astronomical as the first CME.
August 2017, a big month for astronomy. Presented by Science at NASA. Sky watchers in the United States have been waiting for this date for years. On August 21st, 2017, there's going to be a total eclipse of the sun. With the path of totality stretching from Oregon to South Carolina, people can see the eclipse from coast to coast. The timing of the eclipse will provide the opportunity for viewers to see one of the biggest astronomical events of the century, just a few weeks after enjoying one of the biggest meteor showers of the year.